Introduction to Additive Manufacturing, presented by Dr. Amit S. Vaidya, DMS, ISBM Mumbai, expert in CAD/CAM design prototyping with 15 years experience in the field of design. Introduction. Additive manufacturing process. Classification of additive manufacturing process. Types of additive manufacturing process. Advantages, disadvantages, applications of additive manufacturing process. Present condition and future trends in additive manufacturing process. Conclusion. Introduction. Manufacturing is the process in which raw materials are transformed into finished goods. Additive manufacturing is a technology of manufacturing by addition of material. It is a technology that can make anything. It eliminates many constraints imposed by conventional manufacturing. It leads to new market opportunities. It increases the range of applications such as 3D faxing senders, scanning of objects in cross section, and using the digital images to produce the layers and receive the layered images that uses in the additive manufacturing machine to fabricate new 3D objects. Additive manufacturing process. Additive manufacturing process is a process of joining material to make the objects from 3D model data by layer technique. It is commonly known as 3D printing. Manufacturing components with virtually no geometric limitations. In additive manufacturing, the process uses additive process. It is designed for manufacturing to manufacture for design. It distinguishes from the traditional manufacturing technique. Manufacturing process includes creation of CAD model in CAD software, generation of .stl file, generating sliced layer and toolpath in the simulation software, creating a 3D printed object using 3D printing machine, finishing of final product. Classification of additive manufacturing process. Stereolithography, material jetting, binder jetting, material extrusion, powder bed fusion, sheet lamination, direct energy deposition. Stereolithography. In this, laser beam traces the cross-section of the part. SLA is elevator platform descends. A resin-filled blade sweeps across the cross-section of the part. The immersed part is dipped in the chemical path. Stereolithography requires the use of supporting structure to build the part. Material jetting. Material jetting includes drop-off part demand method. The print head is positioned above the platform. The material is deposited from nozzle. The material layers are then cooked and hardened using ultraviolet light. The droplets of material solidify and make the first layer. Later on, the layers are built one on one and the part is produced. It gives good accuracy and surface finish. Jetting. It involves a glue or binder injected from inkjet style printhead. Roller spreads a new layer of powder on top of the bed. The subsequent layer is then printed and stitched over the layer. The remaining loose powder is used as a support to the overhang structure. FDM. FDM is fused deposition modeling. The material is drawn from the nozzle where it is heated and then deposited layer by layer. The first layer is built as a nozzle deposit where required cross-section area is covered. The following layers are added on the top of previous layer. The layers are fused together upon deposition as the material in it is melted state. Powder bed fusion. It is of three types: selective laser sintering, selective laser melting, electron beam melting. It is a process in which a small layer of 0.1 mm thick is spread on a blade platform. The SLS machine preheats the layer. The layers are then formed over the one over the other, and the part is formed. Sheet lamination. In this, the metal sheets are used. The laser beam cuts the sheet into contours. They are glued together by using hot layers. Direct energy deposition. It consists of a nozzle mounted on a multi-axis arm. The nozzle moves along the multiple directions. The material is then melted upon the deposition layer and the part is warmed. Of additive manufacturing processes: 3D printing, 4D printing, 5D printing, 6D printing. Printing. 3D printing is an additive manufacturing process that creates objects from digital design. The process works by layer formation of a material from liquid powder, plastic, metal, cement, which fuses together. 3D printing. 4D printing uses 3D printing to create live three-dimensional objects without wire or circuit. It does so by using intelligent materials which can be programmed to change their shape, size, color when they receive an external stimulus. Such is the case with hydrogels, resins, active polymers, ceramics, or even live tissues. 5D printing. 5D printing is a hybrid technology that involves both additive and subtractive manufacturing technique. It involves the printing of various complex structures using three-axis movement of the axis plus two rotational axes of a printer jet. Printing. 6D printing is an additive manufacturing technique that builds upon the foundation of traditional 3D printing. While 3D printing involves layer-by-layer deposition of the object, 6D printing takes it a further step to incorporate smart materials and additional dimension. 6D printing uses intelligent materials that can adapt to the external stimuli such as light, temperature, pressure, etc. This innovative approach has rapidly gained attention in various industries for different applications. Advantages, limitations, applications. Advantages: freedom of design, complexity for free parts, potential elimination of tooling, lightweight design, elimination of production steps. Disadvantages: slow build rate, high production cost, considerable efforts for applications in design, discontinuous production process, limited component size. Additive manufacturing has diverse array of application in industries like automotive, aerospace, biomedical, consumer goods, and many other industries. Foundation of additive manufacturing: new technology and research, university industry collaboration, technology transfer. Reduces the market time to market, increases the product quality, improves the product performance, and reduces the cost. Education and training helps to empower the people to build better AM. Formal AM education has already been integrated into curriculums. Education in materials help to improve the engineering course of additive manufacturing. In additive manufacturing, technology and research, third industrial revolution, cost-effective mass production, reduced material wastage, energy consumption, adapt new product designs, uh, adapt new application range. Education and training. AM holds a great potential in the education sector of STEM. Availability of low-cost equipments help the opportunity in schools, primary, secondary, and post-secondary education. Additive manufacturing is the process of joining material to make the objects from 3D model data layer by layer. Traditional subtractive machining techniques rely on the removal method such as turning, drilling, milling. It has many advantages over traditional manufacturing process. Additive manufacturing is on the verge of transferring to a rapid technology process. Manufacturing metal components with virtually no geometric limitation offers a high range of performance and applications in various streams. Base journals. books, papers, Google, Wikipedia, etc.